Hello, everyone, and welcome back to yet again our free support Fridays, where yours truly, Fusion Phil, for those of you that don't know, and for the rest of you, world renowned Fusion Phil here, we are kicking off our free support Friday once again. And with that being said, we already got somebody in chat. Great to see you out there, Emil. Awesome to have you guys. If everybody out there, again, if you're new here, the whole idea of these free support Fridays, like always, is we are here to provide content for you guys, support for everybody and anybody. We like to open the doors up so that all of you get your answers. At least you get a chance to ask those questions, get some answers as we hang out here on a Friday before kicking off our weekend. For those of you working overtime tomorrow, I extremely excited for it. We got Joe out there. We got Mr. Doability. That's a new one, Mr. Dude, new guy in chat. Great to see you guys. Always love to see it. Hey, just a reminder for you and anybody else here, if you guys have questions at any time today, we have a couple of things to kick things off, and then the schedule is pretty open. But feel free, throw those questions in chat or use the link in our chat. Actually, the link in this video. I also have another way when I share my screen. I think there's a QR code. You guys can scan, put in your tickets, get your questions out there. I'm here. What are we doing? Let's kick this off. Big shout out to Tony Lusa. I know it was up there before. He did sign up for a top tier lobster plan. And with that, I got to go ahead and look at my other screen here. Obviously, I got to share my screen, but let's dive into it. So we got Emil. Do you like the new assistant? I haven't even tried it, man. We got a guy out there. Is that Augustone from Italy? Again, proving my fact, guys. World-renowned Fusion Phil here. Great to see all you guys. But the new Autodesk Assistant. Do I like the Assistant? Of course I don't like the Assistant. It kind of replaces me. But in a lot of ways, it actually helps out quite a bit because if we fire this thing up right now, from what I'm told, there's this whole AI thing that happens in the background. Now, I'm curious because I don't think it's going to, but it might actually respond back with video links to myself. But as you guys can see, as you're seeing here, you do have the Autodesk Assistant. You could ask the Assistant just about anything. Let's see here. Can you give me more info on 2D face toolpath? We're going to go ahead and try it. I've yet to try it. I don't know. It's one of those things. A lot of you guys out there don't like talking to robots, dealing with call logs, or people that are not in the United States and want to talk to a human, which is where I get my business from. But seeing how long this is taking, we might have to come back to this here in a minute. In the meantime, let's dive into our very first problem. Okay, there we go. Where to start? Geometry. This is pretty neat. I mean, overall, it does give you a pretty good breakdown. Now, as you're seeing, it also gives you the sources. Great thing there. However, it doesn't really give you a video or any real kind of scenario. So I guess that would be my only complaint on it so far. I assume it's only going to get better. Obviously, it'll get better if they feed it our content over here. But let's go ahead and jump back into this. So this is the first part that I have gotten. And to be said, I'm going to show you guys a couple of things here. If you guys missed the content yesterday, we started a new series called Thank You Thursday. That being said, is the ability to utilize our customer base, people that signed up, have worked with us for the last couple of years, to come out, give you guys the story. You guys ask them questions about the industry. Again, the whole goal there is to put some of you out there in front of people. But one thing that was brought up yesterday was the idea of utilizing surfaces when it comes to toolpaths. Now, as you can see here, good news is, guys, Tony told me, go ahead, roast me on this. But as you're going to notice down on my timeline, this is one of those scenarios where somebody is using a ruled surface tool. And what that ruled surface tool is doing is extending the edges over here on this part, right? Now, I'm going to show you guys a couple tricks. Let me know, do you guys like this? Do you not? Is if I go in, again, there is a surface there. And what you're seeing is a continuation. So I want to go ahead and dive a little bit further because I did notice in the case of these parts is the ability to use ruled surface will work on some of these scenarios. And if I go in, I got to remember where ruled surface is. We're going to go ahead and create ruled surface. I think a lot of people miss the fact that if I pick a edge, I could actually pick all 4 edges or all 3 edges in this case and do these in one shot. Now, keep in mind what you're going to notice here is it is going to extend it, and you can extend this in a lot of different ways. Tangent, as you're seeing, again, this is where we have a lot of different ways to toggle different things, getting a different result. So as you're seeing right now, is by utilizing tangent, it's going to directly extend those flat surfaces. With that being said, is by using alternative faces, we go from basically what I would say everything pointed vertical to now pointed outwards. So again, very, very simple way to generate a surface that you could later use for toolpath constraining. Now, the other way I would tell you guys to do something like this is the way I prefer to do it. I think there's a lot more value here. No offense to anybody. But if I actually go create, offset, and then I pick this surface to start, what I'm going to do is I'm actually going to leave it as 0, because if I leave it at 0, it's just going to replicate the face or faces that I've touched. And if I go ahead and turn the model off, again, I'm going to leave some of those other things on. But as you guys can see, right there is the surface that I created with offset. And then I could turn around and use extend, grab my edges once again, extend them outwards. Now, there's a time and a place for each scenario, but if you guys notice, is one, I'm getting a nice extension of the exact profile. I wasn't getting that ruled surface kind of scenario where it creates rounded corners. All of that stuff has come out automatically, and I can keep it very simple. So again, if we go ahead and turn our body back on, now you can see I have a surface to be able to control my boundaries with. So if we jump back over to manufacture, the real question that we had on this part Tony would like to use a very specific tool, which is going to be a tool that matches the angle here at which he's trying to machine. So we're trying to do this in a 3-axis environment. Now, it does look like he did get some results here utilizing a parallel toolpath to follow down that wall. Again, very, very useful at the end of the day. This would be one way for sure that you could set up Fusion to cut this. Now, this is why some of you are probably wondering why he extended his actual surfaces, and that's nothing more than to be able to create that toolpath that will go off of the part. Again, that's the only reason he did the extension of the ruled surfaces. Again, pro tip there, you could have linked them all together instead of having a bunch of individual ones, or do offset extend like I did. Now, a lot of people miss out on this is because if we go into 2D contour, and I've talked about this, I feel like I talked about this probably 3 times in the last year, is depending on what tool you have, there is some secret things that happen inside of Fusion. For example here, as you're going to notice, is by default, we do have chamfers. We also have roughing passes. But the issue is with the chamfer option, we're not getting our multiple depths. And the reason why that's important is because with multiple depths, we can do a tapered wall or a step down. So what I'm going to do is I'm going to go ahead and go back here real quick to his tool. I can never remember which way I need to set up these tools. As you guys can see, he defined this as an engrave/chamfer mill. If we go ahead and say this is actually where is it here? I got to remember off the top of my head, like always, a tapered mill. And then at that taper mill, we have a taper angle. I think what he was telling me, it's 12.5 degrees, which is going to give you a very steep profile. We're going to go ahead and go 0 corner radius. We might actually have to go the opposite way, which I think was 77 degrees. There we go. Go ahead and go 77. And as you can see, I'm basically redefining that tool once again to get an angle that's going to match. So I'm going to go ahead and hit OK here. And for Elijah out there, can you probe something, anything? Yes, we can do some probing. Tony submitted another ticket about probing. But let's go ahead and verify now. So based on making this a tapered end mill, I now get what's called multiple depths. And well, with multiple depths, I get a wall taper angle. So again, this is one of those things that you can utilize in a little bit of a hacksmith way around it to be able to use that multiple depth scenario with a maximum roughing step down. And then if I was to define whatever my edge was here, I believe we're going to have to go ahead and go off this bottom edge. Pro tip, we're going to use the Alt key here real fast. And as you're seeing, I'm coming from the wrong side, which means I do need to flip that around. So let's go ahead and go back in. We're going to go ahead and flip direction. And give her a minute to calculate. So again, as you guys are seeing, one, I don't think I got the angle right. Actually, it does look like I did get the angle right with that 77 degrees. But this is where, again, I'm utilizing the ability to use my 2D contour and step downs with a tapered angle. So again, little outside the box thinking for some of you out there. We went ahead and simulated this real quick, and I got all my angles right. It looks like I didn't actually get my angles right. But you're going to see that in real time as we come across that part. I'm going to assume we're going to get closer the further we go down. And considering I was told 12.5 degrees, we're probably missing 77.5 degrees, right? Now, that is the whole goal there, is to be able to follow a taper, very simple profile here, and step down that wall consistently. Again, guys, I got the angles wrong here. But that is how you can utilize multiple depths at an angle, and your end mill would have to be a tapered end mill. Now, going back here, I still think parallel is probably one of the best ways to go about it. Parallel is a very, very good toolpath when doing things like this. Again, if we regenerate that parallel toolpath, the only thing I would say is, once again, we are using a tapered end mill now instead of a spot drill or chamfer drill to achieve the same kind of outcome. However, with the 3D parallel toolpath, again, if I was to do this from scratch, just so you guys can see, 3D parallel, what is it that you want to machine? Well, I would like to select the boundary. I would also like to add an additional model to machining, which is going to be this guy right here. And the reason for that is, like I said, is I want to extend my toolpath out. However, I don't want that toolpath to waterfall outside of my part. Now, as you can see, we need to go ahead and adjust our angle. So let's go ahead and change our pass direction. And just like that, you're going to notice we're now running horizontally with a very exceptionally large tangential extension to get off of our part, turn around, and feed back in, making you a nice clean transition as well, reducing chatter and other problems. So, what do you guys think? Neat stuff? Anybody learn something new? I'm going to be honest with you. When I looked at it and I saw the ruled surface move, I was like, oh, that's kind of neat at the end of the day. But I could see where it could cause problems with that ruled surface. And as you guys saw, the rounded corners, I don't think it's a big deal for most of you. But if you always consistently wanted to extend a certain amount, keep in mind that rounded corner up at the top would actually change some of that. So with that, we're going to go ahead and go back, because Emil says it even does some commands like create setups. All right. I mean, let's see it. I'm gonna take your word for it. Let's do it. Can you create? Can it only do one, or can you create 2 setups for this part on a mill? I don't know. We're gonna find out. Is it gonna do it? My luck, it'll crash Fusion. I'm pretty good at crashing Fusion live on these live streams. In the meantime, I'm gonna grab a drink here real quick. Can even make programs. Oh man, I can't wait to see that outcome. Setup 1, top side default orientation. Setup 2, well, I mean, it's walking me through it, but it doesn't look like it wants to do it. It's also telling me now to generate face, pick a face tool, yada, 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 yada. I mean, this is cool. I like this. This is way better than what used to the, what is it, the library or whatever. Again, guys, I'm no expert on this. I'm only here that when you guys, if you guys are going to use this, when you have problems with it, then you can just message me and I'll get you taken care of. So let's go ahead and shift gears here. So Elijah, I know exactly what parts you're talking about. We talked about this. Elijah's scared to probe on his Haas machine, but we're going to get back to that. So again, looking at this part in particular, this one was set in by Tony also. As you guys can see, we have our XYZ direction. Now, this is a weldment at the end of the day. There is a pin in here that was also welded onto this. And well, although you could see that we have WCS probing in play for our Y-axis, The dilemma is if he wanted to pick up the X and the Z based on this pin, in this case, he's trying to punch that hole in this part, is if I was to go in, and you could either go inspection, probe WCS, or milling, probe WCS, or my favorite way to do it, if you're going to do a bunch of probing, hit the S button, and then you could also pin it to your shortcut menu, making your life much easier. But if you were to try to actually go in and probe this surface right here, Fusion has no idea what to do. It doesn't give you an option of an X direction or a Z direction. Again, just based on a round surface, it doesn't like it. So again, little hacksmith way around this is to go back to design. And this is where there's a lot of ways you could do this. I think the easiest way to do this would just be to throw your sketch on the end of your pin. And we're actually going to go finish, back this up one, because I'm going to do this the right way, even though this model was a little messy. Almost like Tony's been watching EJ out, or Elijah out there work. So again, let's go ahead and get this turned back on. Let's do our sketch off the end of this pin. Keep snapping me back to the middle of nowhere. So we're going to go ahead and do our rectangle from center. I'm going to go ahead and actually back this up. Let's do this one more time. Right here is where I would like my sketch, Fusion. Why you keep taking me over here? As you're going to see now, we're going to do our 2-point rectangle. Change it out to a 3-point, or not 3-point, but a rectangle from center. Again, as you guys can see, I've now got that generated. I could go ahead and say tangent top, tangent wall. And just like that, I have created a perfect rectangle. Now, keep in mind, if you were trying to deal with a line that wasn't perpendicular to the vertical, and if I was to show this to you guys again, for example purposes, go ahead and get that first sketch turned off. Let's say I want it to align to this surface over here on the right. I could still make my circle on center, use F6 to get back to my part. You guys are wondering where that F6 hotkey comes from. Down here at the bottom, you have what's called fit, F6. That's how you can quickly bring stuff back onto your screen. But this time, let's say I'm going to go ahead and do a rectangle again. Maybe it's still a center rectangle. And when I create that rectangle, this is where I could actually have some problems. One of which, closed out sketch. But if I try to actually go parallel this to this, what you're going to notice is I'm now over constrained, right? Well, this is why you have different settings in here or different rectangular profiles to create. This might be where you do a 3-point rectangle. You could go 1, 2, 3. And then from that, we could go ahead and say parallel here to here. And now you can see we've rotated around. And then, of course, I'll have to throw a couple more tangencies on here just because I'm no longer anchored to the center point. So again, just like that, we've got that rectangle. It's at the angle of this back wall. A little bit of a pro tip here for you guys, as you might guess. But let's go back to our original plan. So now that I have that, what I'm going to do is I'm going to go ahead and extrude that rectangle. Now, again, it's up to you guys how much of that you extrude. In my case, this is going to be a brand new body. And the only reason for that is because this one body in particular is going to be used for specifically my probing functionality. Now, for some of you out there probably wondering, I didn't build this model. This is not the way you should build the model. We shouldn't have two bodies sitting here next to each other. The pin and the body for the rest of this should not be on the same layer as well. So just bear with it. I get it, guys. Job shop mentality. You just got to get it done. So let's go ahead and jump back over to manufacture. Again, one thing I would change in my setup is when defining everything, the model body here should have included the pin. Again, this is a weldment, so it's already been welded together. But as you're going to see now is we do see that pin in real time. Again, let's go ahead and update our probing. And then once again, cheating, hit the S key, go to probe WCS. Now, I'm going to go ahead and go into my probe surfaces. Again, your organization will be key. I'm going to go ahead and get that rectangle turned on. And as you can see, I can now pick two sides of that rectangle to probe. Now, if you're going to live dangerous here, guys, I understand that a lot of you like to. We could always bring that top height down. Could also get down closer to the center line of that pin. And if you know the dimensions of the pin, again, as you guys may or may not know here, you could actually say selected height top, and then you could subtract that by whatever that radius is. I'm going to make a guess that it's 0.5, and you might need to go even further because we don't want to be hitting anywhere that's not technically tangent. So for all of you out there, you could actually add 3 millimeters to this, or in my case, we don't need to add, we need to subtract the 3 millimeters. Go ahead and redo my math here. We're going to offset minus 0.5 to get down, and then we're going to add another minus 3 millimeters, is it? Doesn't like both. Can you imagine that? Probably because I'm in this live meeting right now, like always, trying to do one or the other. But I think you guys are kind of seeing here. We're going to go ahead and guesstimate at 0.6. Call it a day. But the goal is just that. To be able to drop that down. Again, what I'm trying to do is that's a 6 millimeter probe. We should be able to drop by 3 millimeters more. But now you have your x-axis probing. And again, I could do another probe WCS here. Deep thinker out there. Pin is just for probe reference. Ah, I see. So if the pin was just for probe reference, again, I could have joined those two together. I didn't need to add it in the setup, but I think you guys are starting to see this in real time. Once again, we could do our probe, top face, Z only. And once again, if you didn't want to wait for this thing to jog all the way down, we could, of course, drop that Z height a little bit. So with that, we are now picking up Z technically off the top of the pin. As well, pro tip here for a lot of you guys, I would highly recommend that if you are probing in the x-axis fashion on something round, do the x-axis before the Z, because if your Z was over here to the left, you would be low. If you were over here to the right, you would also be low. You want to try to get on top of that cylinder as best you can. Leon out there, great to see you, Leon. Glad to have you here. Well, with that, what do you guys think? Fancy? Not fancy? Let me know in chat. I'm going to go ahead and jump over real quick. I want to check the ticket system because I don't see any new tickets in at this time. But seeing how the topics here tend to get into more of probing today, do you guys want to talk more on probing? What do you want to do here? I'll give you the chance to throw it out there. How do you probe under a hat for Op2? This is one of my favorite things. I don't know why I get this question so much, but I'm going to go ahead and steal this part right here. We're going to walk through it. 3D contour model you sent earlier this week. Ryan, let me see here. I got to try to pull it up here, Ryan. Give me a quick second, guys. If you are wondering, Ryan, where did you, was that a ticket or? I'm looking in the wrong area of my ticket system. I think I closed it out, but let's see here. One sec. Ryan, all right. I think I got it here. I'm going to go ahead and get this pulled up here. I must have closed that out like an idiot. I meant to have it here for you guys. So you guys are going to have to watch me upload this here real quick. Downloads. Go. And we will take a look at that. So while that's going on, though, I guess the question is, let's say, for example, you're doing this part, right? I'm going to go ahead and scrap this. We're going to start fresh here. Brand new setup. XYZ. Beautiful. Stock size. Fixed size box for the win. We're going to make it a little bit thicker here. Let's say 4 inches. And we're going to do my favorite offset by the top. I don't know. We'll give it 50 for cleanup, right? Let's go ahead and get that model also put back in there. We don't want everything. We only want this guy right here that we're working on. We don't want all of that. Hold up here. Just this guy. There we go. So, basically speaking, anybody out there that doesn't know, let's say, for example, you're going to rough out this part. I'm going to use 2D pocket clearing. I should have a good old fancy bolt nose. Let's just say you're using like a 1-inch kind of tool. This is a pretty good size part. No boundary. As I'm looking for right now is we want to go ahead and get that outside all cut away. And now I'm stuck with a hat when I flip this part. So if I'm doing a part that involves multiple setups and I would like to do probing at some point in the second setup, what I'm going to do is first and foremost, of course, is get my setups defined the way I want. Now, Z should be up based on a flat surface. Lastly, our stock is from preceding coming through automatically, which means now I have the actual stock to deal with. So first and foremost, as you're going to see here, is I would deck off the hat or machine off the hat, depending on which way you're going about this. So let's go ahead and do our face toolpath here. Multiple depths for good measure. I don't know, what do you guys feel like? 125 thou? That should be plenty, right? So now I've decked off this part of the part, and I've realized that here's another one that I see quite a bit is we didn't go deep enough in the first setup. So this is where you can verify things. This is also why I firmly believe and love the idea of when in doubt, okay your way out, because once you start to see the outcome, we can go back and make those changes. Let's get back to our first profile. We're actually going to offset. Let's go ahead and go minus 50. That'll take us far enough one way so that when we face off, we no longer have that little skim around the outside. Now, again, you guys are going to notice I program a little fast and I don't concern myself with certain things like where is my WCS going to be? Where am I going to hold this part? How am I going to do this? Because I want to run into those errors once I get tool pass on the part to make a decision like, for example, I don't want WCS in this case to go off of what would be that stock from my first setup. It's extremely inaccurate. This is where I might start to do something is, let's go ahead and rotate my part here. I do luck out that I have a parallel or a perpendicular to my setup kind of face here. That would be my first decision at the end of the day is, can I go ahead and use that for a stop in my machine? And I think that would be acceptable. So that's where I would define a model box point. Now, this is a pro tip out there for you guys. In your setup twos, even your setup ones, I always like to go off the bottom of my part and work upwards because, again, if this is against a stop, this is flat on my parallels. And lastly, if we rotate sideways, I'm also square here. There's no reason this part shouldn't sit flat in the vise, right? That is the goal here. That's what would work very well. Again, guys, I know a lot of you out there looking, why wouldn't you machine it from the side? Because we're demonstrating taking the hat off the part and also utilizing something like WCS probing. So with that, again, I may have my machine stop here to hold that part. I'm going off the bottom, which should be flat because we should have machined the other side a lot more than I did. But the whole goal here is once I now deck off the hat, is I can then follow this up with my WCS probing or whatever you want to do at the end of the day. So now I could go in and probe WCS. I'm going to probe across my actual X location. Now keep in mind, you may need to move this to wherever you need it to be and using that OK button to get my probe quickly. But now I'm picking up my Y-axis center. I can then WCS probe once again. We're going to go ahead and go off this end, single point, because I have a taper back here. Now, this might be the one thing that I see a lot of people confuse at the end of the day, is I do not need my probing to be directly over top of my WCS. This is very, very important. The same reason for that is because if I go back to setup one, again, extreme laziness over here, guys, is thinking about this is why wouldn't I use the same point for setup one? Then I have one vise, two setups. I don't have to switch jaws out. I don't have to do anything crazy. And the only difference would be is my stock box point, same bottom right corner. So again, now when this sets in on my parallels, everything works nice and pretty. We're against our stop over here to the right. And then we flip our part over. Again, yes, you're going to need a stop a little higher up for this particular part. But what you're noticing is I'm using both of those locations to my advantage, right? Again, minimizing how much work I got to do at the machine and maximizing what I can do inside of Fusion. So just like that, we've now faced it off. Again, I've picked up my probing points, and then I would basically go ahead and continue. If you're like me, of course, you're going to go ahead and throw a little chamfer around this part. Now, one thing about this part that's a little screwy, I don't know who designed this part. I don't know why there's a massive hole through here. But as you would see, I would then put my chamfer tool in. My chamfer would all be aligned nice and pretty if I was to go down that avenue. We're going to go ahead and throw it on here since it's taking me this way anyways. 1/2 inch, 90, finishing. And just like that, it's actually deburred that and gone around that pocket. So I'm going to go ahead here. I think my chair has broken. Let me get scooted back up here. Like, why do I feel like I'm sitting on the floor? You guys wondering why I'm melting? But let's go ahead and do a few more things. So I do see a question here. Is it possible to probe a pin center and upper surface and fit the finishing mill length? Fit finishing mill length. I need a little more information on that as to what exactly you're asking. But let's go ahead and pivot. Again, we could always come back to this. As you guys, I just closed my chat out. Hold on here, guys. I can't see chat now. Where is it? There we go. You guys are back. Great to see you guys. Did any of you guys catch my content yesterday? Did you like it? Was it kind of interesting to see? So, now we got our part pulled up. Let's go ahead. Jumping back over. Ryan, what was it that you were trying to do on this part? Trying to contour the large 4.5-inch boss on this part. And unable to do it with 3D contour. How contour the external part of the bore? So, let's see here. Is there some undercutting? What do we got going on here? We got a nice little concave kind of profile. We got a little warpage going on here. So the question is now is how could you run around the outside of this bore? And I would assume what he's really looking for is to get this chamfer or this fillet down at the bottom more than anything. So with that, there's a couple of toolpaths that would work out good for this. So let's go ahead and jump over to manufacture. I'm going to go ahead and turn the old fans on the computer. Got to turn the jets up like always. So there's our part. That's what we're machining. Let's go ahead and hit this with a 3D pocket clearing real fast just to get some material out of the way. Seeing how he went ahead and told me that there's a 4-inch bore in play. Let's go ahead and where is it? 1-inch spool again. Aluminum roughing. No boundary. And let's get a toolpath. As you guys are seeing is what I'm trying to do is just rough this part out. Now I am getting some weird stuff here. Probably because my depth of cut. Again, we don't know. That would be brutal. 1.125 depth of cut might be a little crazy. Now, something I would tell you guys is if you are doing parts like this, I'm going to go ahead and get some stuff out of the way. But if you notice, I would need additional step downs in here to clean this up more before machining. Or this might be a good output of utilizing the actual multi-axis clearing strategy because this is what's going to drive which way our tool points. So if I actually go in and I say, this is my floor surface, and with that floor surface, we're going to go ahead and allow a 4th axis kind of strategy. And the reason why 4th axis is because, again, I have a curvature only in one direction. So again, we're going to go ahead and go set up X. Beautiful. Rotary origin. Again, we could actually say selected point from the arc. Now, in this case, I don't want that in particular. I don't think it's going to give it to me as the arc center. So we might just actually leave that. Let's go ahead and say model origin, not model origin. Set up WCS origin. And we're doing a pocket strategy. Same kind of thing. Maximum roughing step down, 0.125. I want to see what this is going to kick out for us to be able to rough that out and maintain that tool perpendicular surface. While that's calculating, let's go ahead and shift gears a little bit more. Of course, we got an error. What's it wanting? Try increasing the clearance setting. Okay. Let's go back one more time. I'm more than certain, if you guys weren't wondering, the problem would be is either which way my tool is pointing with that floor surface, or it's going to be the rotary axis, which means we might just fake it out with a full 5-axis toolpath and call it a day. Let's go back in here. Full 5-axis for the win. Maybe. Now I'll probably have to flip tool again. But when we're looking at doing this kind of wall and this fillet, because of the angles and the curvature, again, if you guys are unaware of if a surface is flat or curved, a good way to look at that is going to be under inspect. And then you have what's called zebra analysis. So looking at this part, as you're going to see, anytime I kind of rotate my camera is going to determine what's happening. So as you guys can see, as I increase more or less the stripes, I am getting a lot more striping across this face, which means it is not flat at the end of the day. There is a few other settings here that you can look at. Now, you would have to go back to design to see some of those other settings. So if we go back into design, you have curvatures. Again, if you're looking at specific surfaces, you can go ahead and see curvature that way as well. So with that, let's get back to the original question. The original question was, how are we going to find ourselves to be able to machine more or less this little ball corner and utilize our Z-axis to our advantage? This is where I think what would be beneficial is something like a pencil toolpath is pretty decent at the end of the day. Now, keep in mind, the pencil toolpath is designed when you're going to use a tool corner radius smaller than the actual radius that we're trying to machine. That's just something to keep in mind when you guys are dealing with something like that. I think in my case, the blend strategy could be pretty powerful here as well. So if I was to say blend, let's go ahead and pick a smaller tool. Ball end mill. Let's start with something around 1/4 just to see what we can get. Now, the blend strategy in itself, of course, we have drive surfaces. This is where I can pick my wall as well as the corner radius that we're machining. I do want no boundary to start with, and we're going to use my favorite thing. When in doubt, hit OK. And as you're seeing, the whole problem is our drive surfaces lacks drive curves, which means I got to give it more or less 2 rails to go between. So I don't know how well this is going to work. It's always fun first time you throw something out there, but we're going to see what happens. In the meantime, I see a ton of you out there. And with that said, if you guys have questions, throw them in chat. Does the QR code? Did anybody use the QR code? Does it work? Again, QR code out there. The QR code's goal is for you guys to quickly get to our support site. And then from that, submit tickets to get your questions answered today. Now, before I talk more about what's going on here, as you can see, it did kind of work. But it wouldn't be right of me not to go ahead and get you guys with the old-fashioned. If you like this content, you guys are liking what you're seeing, learning new stuff here, feel free to support this channel in any way that you like. Again, it's how we keep this content free. We keep this content free through things like likes, subscribes, the ability to sign up for subscriptions, fueling me with beer, lobster, steak, and lastly is anybody that is a paying customer through us over here at JetCAD Cam. Again, buying your software, buying post-processors, all of that goes into the tank to help support this channel and keep this going on Fridays as well as throughout the week with all of our live content. So let's go back. Let's look at this toolpath now. As you guys are going to see, go ahead and check something because it looks like, yeah, it got a little quiet there. Did we lose you guys in chat? Oh, well. But as you're seeing here is I am getting a toolpath that is doing exactly like I kind of called for. Is it's blending this top edge to this bottom edge. Now, for some of you out there, yes, it's a little ugly. So I might refine that by changing not only my drive surfaces to remove one, but changing my 2 edges that I selected. Again, blend in between these 2. Again, tool is too big for something like this. But what I'm really looking to do is to come up with a way that is going to successfully follow around that curve. Now, as you're seeing, cannot calculate toolpath on my latest changes because there's more than likely no room for the tool to work. A few other toolpaths I could look at that I think would do wonderful here is, it's not very often I say this, but sometimes the flow toolpath does quite a lot. But again, what you're going to notice is we grab our flow toolpath, go ahead and make sure we have some decent step overs here. Go ahead and go 5 thou. Do you guys have this problem on your Fusion where your tolerances have all disappeared since the last update? Or is it just me? Little crazy. But let's go ahead and see. Are we going to get anything? We're not going to get anything, period. It is just like, nope, not going to happen. Partially makes me think that my drive surface is off, or it knows that it just can't fit that tool in there. And that is the case, because we are starting to see a toolpath form the whole length of the part for going back and forth. If you have a ball and mill, that, yes, so 100%. So I'm leading up to that. Now we do need to go ahead and either measure anywhere we can. Let's go ahead and get an inspect here. Is in this case, you have an 047 length. This isn't giving me a radius. But a few things I do want to point out here is if you are looking to do something like this, the goal would now be is looking at our ball end mill, but also you have what's called minimum chorded radius, should be 030. So what you're going to see is we're going to go ahead and pick this. I'm going to go ahead and plug in 030. I think somebody came over here and turned my number locks off. Let's go ahead and see. As you're seeing, an 030 would access that area. I went ahead and enter a little too fast. Get this spread out. So that is radius based for those of you that are wondering. If we go ahead and up that to 060, it does look like 060, but I am not plugging in the numbers in the right area. So as you're seeing now, 030 here, and let's just say this is 1.25. It looks like it's actually still less than 030, ever so slightly. Now, that could just be, again, based on the tolerancing of the model. So, we're going to go ahead and call it 030 for what it's worth. So, let's do it. With that said, again, there's a lot of different toolpaths you could do. Now, if your customer wasn't super particular about this surface, one thing I would say is a 2D trace might work quite well and be just enough to get the job done. So what I'm going to do is, again, we're going to go back to my Fusion library. Should have a bowl end mill with a 30 thou radius. I'm not seeing anything in here. Let's go ahead and grab that 1/2 inch. And let's go ahead and paste this in. And we're going to edit this here real fast. And we're going to get that cutter. 030. And there we go. So let's select that. Now, again, a lot of different ways for you guys to do this is we can do our curve selection. Now, I am going to select this upper edge. And if I hit OK by default, you're going to notice, one, it plunges straight on center, but I'm also failing to get to the proper depth. So this is the two things that I need to pay attention to, and I can fix them either both at the same time or individually. You're going to notice here in my heights tab of trace, the big problem is going to be is that I don't have a bottom height. And that's because trace prefers to utilize what is referred to as axial offset. We do see this when we start to talk about more multi-axis toolpaths. So if I go in again, and we're going to go ahead and say a negative offset down, and then I'm going to set my cutter comp to either left or right, depending on which way you prefer to machine. But just like that, I am now running around the part, and that blue line is going to dip and increase as it goes around, giving me more or less that fillet as well as wall finishing all in one shot. Now, again, if I went down to a 1/4 inch cutter, still had a 60 thou radius, it might be suffice for your outcome and what it is that you're doing. So we're going to give Ryan a minute. Ryan, what do you think? Is that something that's going to work for you, or should we keep going with some more wild stuff? I am also checking my ticket system one more time. Make sure that no tickets are in. We're 45 minutes into this already. Woo! Got a lot going on. The next couple of things I would say, if you're looking at, should work. Better than you were getting? Awesome. So, again, just because we're dealing with a very flat face, or not flat, a non-flat face, however, it is what I would call a shallow face. A few other kind of cool tips here is geodesic is great for stuff like this. So you could do a geodesic toolpath, again, drive surface here, and then you could do things like a scallop or blend strategy as well. But the goal would be is based on 5-axis, and then lead and lean is the important part here, because by setting everything as a default 0, it will keep that tool perpendicular to the surface. So let's go ahead and grab that 1/2 inch cutter again. Slotting just because I want to do a pretty likely big cutover. And in this case, I totally forgot that you can't use a bowl end mill with geodesic. We would actually have to go back and use a ball end mill to be able to do geodesic. And let's go ahead, aluminum finishing. Change my tolerances because Autodesk updated and dropped all my tolerances. Again, geodesic, great toolpath to be able to kind of hit surfaces like that. But that's also why you have something like multi-axis finishing. Again, very similar to geodesic. However, you could do things with bowl cutters. You could also do things with the ability to use lens cutters and all of that fun stuff. So getting back over there, tried every 3D one, none of them worked. Yeah, I think for this case is the blend strategy would do all right. I don't like some of this little stuff here. Now, that is probably more than likely caused by the fact that I have tolerancing all over the place. So if I was to give it a little bit more tolerancing, let's say 1,000, a little bit of smoothing as well, we should be able to clean that up quite a bit. And this could also be caused by the fact of how close we are maintaining our curve selections and our boundaries and things like that. So we're going to go ahead and give that a moment, like I said, to calculate. Now you can see just by upping my tolerance and turning on smoothing, again, night and day different toolpath. We got a couple little finicky areas here, but not the worst of things, right? We could obviously increase our tolerance more to get more of that out of there. So we got Jimmy out there with a question. Is trying to extrude a many faces at once. Fusion keeps crashing or become unbelievably slow workarounds? Question mark. So Jimmy, there's quite a few things I could tell by a lot of people's workflows is when you're in the design workspace of Fusion, I'm going to go ahead and pop open a brand new design here, is you have to be self-conscious about your timeline. And the reason why I say that is if you guys have ever seen like a pegboard or a jig plate, and I'm going to do this kind of quick here. Let's just say, for example, I'm doing a 24 by 24 kind of grid. Let's get this put in there. 24, 24. Actually, let's make it fancy. Let's go 36. And then at some point, I'm going to put some type of pattern on here, right? So if I was to take this guy in particular, we're going to do a 2-inch pattern with, I don't know, 625 holes, right? The issue I have a tendency to see is when you take something as simple as a sketch, and I'm going to pattern this. Some of you are probably already like, oh my gosh, this guy's crazy. But let's go ahead and do this. We're going to go ahead based on spacing. We're going to do 2-inch spacing in both directions. We're going to go symmetrical in all ways. And then we're going to just keep populating numbers until we get some, right? Is every time I make a circle right now, I have to extrude said circle, right? So we got 17 that way. We're going to take a guess. Hopefully it's 12 the other way. I think it's 11. Beautiful. As you're seeing now is I have all of these sketches in play, right? 15K faces. Jimmy, I'll have to take a look at what you got going on. But if I was to take this right now, and normally you guys would think is like, oh, I'm going to extrude all of this to give it depth. And my system will even start to slow down a little bit. It's when I come back now, do another extrude, again, turning back on that original pattern. I go ahead and highlight everything, unselect the middle. If I can unselect the middle, I don't think it's going to let me. But the goal would be is now, yeah, it's backwards. Let's go ahead and do this. Get the body out of the way. Sketch on, highlight everything, unselect the middle, now extrude, is based on your entire timeline when you're starting to do stuff, is it starts to get cloudy, and this is too many steps along the way. Now, Jimmy, you may be having a different problem. I'm just putting that out there for anybody else. This is why we highly recommend, 1, taking training with us, but 2, is to not try to do everything at the sketch level if you don't have to, right? Because now the next problem would be for a lot of you is, how do I chamfer all these holes? How do I do this? How do I do that, right? Is if we were to actually go back to when we were doing the sketch, is instead of trying to do all those holes at once, let's just do a individual hole, is with the inner and the outer, let's say it's 1 inch. Now, this is where, again, timeline does make a lot of difference. Is you're going to notice, once again, yes, before I could have just extruded everything and had my holes all the way through. This time, let's say, for example, I don't want the holes all the way through. So I'm making it its own feature down here. Same with if I wanted to chamfer these holes, right? So let's go ahead and throw some chamfers on there. So again, all these holes need, a 20 thou chamfer. Well, the more and more things I do to this is on the time that I need to take something and create an extensive pattern or multiple instances. when you guys get into mighty bites and pallets and crap like that, this is where this comes in handy, is I'm actually going to pattern from the solids menu, and I'm going to pattern the features themselves. So again, is if I go down to my timeline and grab both of my features here, again, we define our axis of direction, and then just like we did before, do everything based on spacing, 2-inch, 2-inch. I think we were, what was it, 30? No, it was like 17, wasn't it? 17, symmetrical. And then this way was 11, symmetrical. And what you're going to notice happen, actually, it looks like we can go up by one on both sides there. Boom. I was wrong. It was 18 by 11. But this is where we have that ability to create patterns. Now, some of you are like, holy cow, you just crashed it. Doesn't make sense. That is because it's a user error more than anything. If we go back to those features and grab our two features, pick our axis, what's happening is because by default, when we did these, it's trying to compute identical. We can actually allow this to do things like an adjustment and other optimized as well. So if I go identical, it seems to work. But if I start to scale this up, again, spacing, we have 18, 2 inches apart, symmetrical, and then it was 11, symmetrical, 2 inches apart, is if I hit OK here, we're probably going to get the same error all over again. Now, this time it did calculate, but if we go ahead and adjust things, funny how you could say adjust or optimize, you're going to notice that your issues go away, right? Because it is trying to optimize your timeline and optimize those features. But the cool thing about this is that anytime if I actually kicked back my pattern now, use the hole tool here. Let's say we want to pop a hole in the bottom of this, and this is going to be a threaded hole. There's going to be a chamfer on the top of it because engineering hates you, of course. That's you know what? Let's go 82. Let's make it difficult, right? But we're going to put a half 13 hole down here at the bottom. And that hole does need to go all the way through. Again, the whole goal here is to continue to add whatever type of information you need and get that all set up in real time. So I think in this case, I can't do a 1/2-inch hole. I think it did need to be smaller based on the size. Or I broke it when I created a hole. So let's go ahead and create a brand new hole. Even the best of us from time to time do a little too much at one time. Go 3/4 deep. Apt. Funny how it's starting to work now. 1/2-inch. Okay, we're good. Let's give her a little chamfer on the top. And I think we're good. And we're all the way through. Beautiful. So as you're seeing, once again, by adding another feature to my timeline, if I jump forward, I can then simply edit that pattern, grab the additional object, which is the feature, and then just like that, we've popped those holes in everywhere. Now, I learned this lesson very, very hard a lot of years ago, way back when Fusion wasn't as optimized as now. Some of you are probably shocked at how well my computer is handling this. Again, timeline cautious, right? My conscience is telling me that this should not look like Harry Potter's volume 1 through 7. Is there 7 books of Harry Potter? You guys will have to let me know. But with that, I see it a lot where people do stuff like this and then they get a little wild and crazy. Now, why this is so important, and I'm going to shift gears here a little bit and start talking about assemblies, is if you noticed when I created this part, I actually said part because this is my plate. This is the plate I'm going to mount in my machine. I save this. Again, as you guys are going to see, this is just going to be pegboard or VF. I don't know. This fit on VF4 maybe. Is when we start to talk about assemblies, you're going to notice this starts to roll up very, very heavy at the end of the day. Now, whether you go hybrid or assembly design is up to you at this point. The only reason I say that is because if we create an assembly, you do still have the ability to create components in the assembly, or you can go traditional hybrid design. But what I'm going to do now is I'm going to insert a component, and that component is going to be my pegboard. And once I bring that in, I can then start to stack and do things on top of that. Maybe I want to put a plate on top of this, right? So again, I could do a new component. Now, what's going to happen with new component right now is it is going to create an external file automatically, just like you guys saw me do the pegboard. So let's say this is my subplate. Now, again, we're going to go ahead and hit OK. And now with that, I'm now in the ability to do what would be kind of edit in place traditionally. Let's say I create a sketch on top of this plate. I now get my hole patterns and all that pull through. Maybe I just drop a rectangle here. Yeah, let's do it like this. And what we're going to do is use some tangencies because I want to go tangent off this arc because those dowel pins are actually there to square my part up in the machine. And then let's say we're going to go ahead, I don't know, 8 by, of course, I'm picking 2-inch increment numbers versus like something weird, right? But as you're seeing me do now is I am utilizing exactly that. I'm taking things from one side and moving them over to the other. Now, yes, guys, this isn't absolutely realistic to do it this way. Obviously, as you would see, I would have just made a stock and then put a joint here. But that now allows, when I hit save, to push everything back out. So now, maybe this is TAC 101 plate MFG for manufacturing. And we'll give that a second to save. So if we go ahead and look at my file repertoire now, I have the subplate, I have the pegboard, and I have the assembly. But notice how Fusion is even showing that to me in real time. One really neat thing about this for a lot of you out there, I did see a customer with a really, really good idea, and they were like, well, what if I wanted to add some holes for specific things here? Well, you could always edit in place your original part, right? So I can modify my pegboard at any time. Let's say we're going to go ahead, throw a little rectangle over here because I want to do, I don't know, like a slot or something, right? And I got to mill this into it. So if you're going to do certain things here where you're trying to reuse that subplate as much as possible, what you'll notice is I can manipulate that here in the assembly. And because of it being linked, every time I go ahead and update and hit save, it will then push the latest and greatest back out. Now, one thing that's cool is if you go ahead and click this little link, you're also going to see that will automatically issue the save and push things out as well. So just a little bit different thinking at the end of the day. As you're seeing, we hit save now officially. And everything's going to roll up to version 2, version 2, version 2, and so on and so forth. So, any other questions outside of that? I know that's a lot to take in. It's like drinking from a fire hose. I highly recommend for a lot of you out there, I know it's going to feel weird at first, but if you start to use assembly and part, I think your workflows are going to work much better. And the reason why I say that is, yes, your files will be a little more cloudy because each individual component is going to be its own externally referenced part. However, it will highly, highly reduce the chance of dealing with things like ill-placed components. And, you have a component down here with the individual surface. I'm not blaming anybody, but this is a very messy file because the moment this component was created, it then turned the entire file into an assembly. And this assembly has a body at the top level, which is a big no-no. If we go back to pin probing here, not to pick on old Tony Lusa out there. Shout out to Tony for being a top tier support subscriber. But again, failure to make your component in the right location. The component fell under the blade body. Now the blade body has a body at the top level. And if you guys are wondering what I refer to as level, when we collapse all these down, pin right here, and then body right here. This is a no-no at the end of the day. A better way this should have looked is if I quickly try to undo what I'm doing here, is if I create a component, now you'll notice is there's a pin and there's the body for manufacturing, right? So this would have been the smart way to do it. Not really have anything here at the top layer of the assembly. Again, getting back into the idea, how I designed this pegboard and everything, moving into the assembly view. The assembly view forced me to link everything externally, and that will always keep you putting your sketches, your extrudes, your bodies in the right compartments at the end of the day. So I know, I just little rant there for you guys. What do you guys think? Yay, nay? Good stuff, bad stuff? Fusion Phil should shut up and start drinking beer? Well, it seems chat has slowed down. Seems like people have stopped coming in here. I don't see any other support tickets at this time, so let me give you guys a moment. But before I go ahead and shut this down, again, guys, you like what you saw today, learned something new, you guys can buy me a beer, steak, lobster. You could sign up for a beer, steak, or lobster subscription as well. That does continue to support keeping these sessions free as well, opening up the doors to other people and getting your answer or your questions answered in more of a public environment. Now, if you would like more of a personalized one-on-one session or support because your customers don't want anybody to see what they're doing, that said, we offer one-on-one support. We have our top-tier support packages, custom on-site training, custom post-processors. The sky's the limit over here at JitCAD Cam as long as you can pay my favorite price of 2 blank checks. So, with that, guys, no other questions? Well, I think this concludes yet again another Friday. I am super excited to always be here for you guys. If you guys have any questions outside of this, watching this at a later date, feel free to throw a comment on this video. Send us an email with the email links down below. Again, I'm going to do my best to try to get to most of you that send in tickets throughout the week. But just remember, again, anybody on a paid support plan does get head of line privileges. So as always, guys, have a great rest of your week. Actually, have a great weekend. Hopefully you're not working overtime. However, if you're working overtime, man, get that money. But see you guys.